here we are at Vancouver Mini Maker Faire. Let's see what's going on here. This is the first time I've been to an event like this. Let's see what's going on. Nice bicycle with some LED signage on it. Let's see what we've got on this. We have their ST microcontrollers. Looks like this is cameras, and they'll project that projector up onto these metal screens over there.
Steady, safe, cheese. Now you just wait for a second while it goes through 7 different cameras. It takes a picture with each of them.
What are these things?
There you go.
Thank you. So this is sort of a reverse picture frame?
He's reusing frames and recycled camera and projection equipment.
Nice.
Yeah.
Messy workbench. And Laser Cutter Cafe. I think this is a shop that's opening up where you can take things to get laser cuts. It's like an interesting thing.
I was going to visit the can't see anything.
Here's the display from the Vancouver Electric Vehicle Association. We have 2 vehicles here, John Stonier's electric Porsche and this other ATV type vehicle. Obviously this has lead acid batteries. What do we have? I'm sure you this is not amphibious, this is just as a demo. Where is the motor on this? Oh, it's on the other side. So there's the motor, good old bricks and strap E-Tech. Yeah, this is pretty simple. And this, we have another E-Tech driving a outboard motor. Contactor, Kelly motor controller. So there's the controls on the opposite side from the power connections. Some pictures of that. Some sort of lithium-ion vehicle here. And here is the Porsche. This has got Thunder Sky lithium-ions. I think this has about 120 volts worth of 160 amp hour. It's got hot water heating, so they use the original heater core. Boxers with fuses and contactors. It's got a Bruce, I think it's an NLG5 battery charger. It's a really high-end unit, so like $4 grand. All looks very nice. Some EV displays in the dash. There's looks like an e-meter. There's the power controls. I think this has 2 AC motors, 2 controllers. We've got 2 contactors. There's a DC to DC converter, IOTA. but here he's going to change it out for a bi-core unit. A bunch of wiring for, I guess that's the original car wiring, and he's got an lithium BMS, the same as my car has. Here's the interface for the Brusa charger. Discharge curve for the Thunder Sky, pretty flat. And just basic stuff about the car. Next step to upgrade instrumentation, more cooling fans. Partly the motors run very hot, like they're running up to past 100 degrees Celsius, so they need better cooling. It's got twin motors mounted where the original engine was. Yeah, there's a better view of that. More batteries underneath. Oh, very, very nicely machined battery racks. This is a really, really nice conversion. Lots of 3D printers here. We have some rep wrap,
All of the black
box.
right here.
Some other odd vertical ones. I haven't seen anything like this before. Dispensing with the original gantry design and going with something that's print type. It's like a small rep wrap.
A while ago. It's actually years ago somebody built a milling machine. Everybody went gaga around water.
This one is called the 3D Touch. This one has some really, really nice machined extruder heads. This looks really nice. It's quite a big build area too. And looks like this one supports two different material types in one time. There's two heads. I wonder if those are for support and build material, or if it's just two different types of build. Anyway, this looks really, really nice. Maker Faire Replicator 2 with lots and lots of different things that have been printed.
They had a kind of
Pretty much. accuracy, and then below that, you need
More MakerBot.
I don't actually put
This one called here, which is MakerBot Replicator 2X, really some sort of a prototype.
Yeah, I was just talking to him about that earlier today. Yeah. It's gears that appeal to me.
I mean, in a machine shop or something.
Yes.
Just get hard-ended on it.
By 3D Design. This is the one we've seen on Kickstarter before. We have this one, Tesseract Industrial. This is a local group of people who are working on some printers. These guys are doing their own 3D printers. Tell us a bit about this one.
This is a 3D printer made by Tesseract Technology. We're just in the development stages. This is the prototype printer. And as you can see in this printer, we actually have an all-aluminum, chain-driven design, which is going to allow for both speed and better wear and tear on the parts. And one of the big things that we're hoping to be able to do this eventually is the idea of being able to switch the tool out to something other than a 3D printer, or be able to hold multiple 3D printer extruders. So you'd be able to do support material and your primary material in two separate materials. And that'll allow you to print either bicolor or with stronger materials. There's a common thing in 3D printers that you basically have to start with a flat surface.
Yeah.
If you're able to print with support material, you don't have to start with that flat surface anymore.
So you're going to have two extruders, one for support, one for material.
Well, it might even go further than that. It might even go into 3 extruders, depending. Because
yeah.
we've built a carriage that is so engineered and so strong, we'll be able to put a lot of weight on this without being able to have to worry about it
Right.
increasing its wear.
So you could put a milling cutter on it, for example.
Exactly. So one of the things that we're looking to do is, as soon as people start getting the product out there, we're probably immediately going to release a Dremel tool holder, so that
Right.
people can swap it out for a Dremel bit and things like that.
Nice. Any idea what this will sell for?
This is going to be selling for probably about $2,000 to $2,500.
So not
And
too bad.
It's got Ethernet integrated, so it's not have to worry about communications like that. We're hoping to actually be able to include a slicer inside of it, so that you can actually send it 3D models.
Oh, like
and
send
not
it an
even have to
STL?
Have an actual program
Cool.
running it.
Yeah. Are these some of the things that's printed?
Yes. So this is the classic lamp. And you can see actually this piece of a wind turbine blade, was actually printed on this one. And while this one doesn't look as pretty, it's exactly the same engineering concepts as in the smaller one.
But it's much, much bigger.
And it's much, much bigger. And
Yeah.
the really cool thing about the way that we've engineered this is that you'll be able to scale this up to 3 or 4 feet, 10 feet wide if you want. All depends on how you really want to do it. And the only thing you'll need to change is the length of these bars and the length of the chain drive.
Nice. So no one else is doing anything like this right now.
Basically, nobody else is doing something that's quite as scalable as this.
Right.
Now, we originally thought, okay, bigger is better, and so everybody wants big. But as time has gone on, we've sort of learned that people can't really host big ones in their house.
Yeah.
So we're focusing mainly on our small product right now, but with the idea that people who understand how to do it, who really want to, will be able to scale it or buy the larger product as a kit.
Sure, that sounds really good. So this is, you can print huge items like this. You printed these, some gears, and this looks like a drive for like a chain drive.
This is actually a tank tread. So this is the tread, and this model is up on Thingiverse, and then the tread goes around this, and you apply the motor. Now in here, you can't really see it, but it's this kind of gearing system.
Nice.
And so what that means is that you apply rotation here, it goes through this, and then, back out to this one, and you can see that this one is actually rotating in an opposite direction and is much gear reduced.
Very high reduction.
Yeah, high reduction. And so this is using the same essential idea where the power is applied in the middle, and that will go through all these different gears to make a hugely gear reduced.
Yes.
And with 2 of these, with just simple motor control, you can get the same kind of accuracy that you will with stepping because you're getting that gear reduction.
Nice. Anyway, thank you very much.
No problem.
And yet more 3D printing. This is the Lido and the Ditto 3D printer. Here's a quad rotor. Well, actually, I wouldn't call it a quad rotor. They take rotors. It's an octal rotor aircraft. It's used for aerial photography. 6 rotors are there. And it's looks like you have some control stuff. So you could program the route on an iPad or something like that, and it controls it. And drone up there. All carbon fiber construction. Looks like you got a couple of RC light poles up there. Lots of motor controllers.
We look around, it's a really amazing
Nice
stuff.
upright motors.
Pretty like, the first time I came here, I was demonstrating how to make bacon.
sort of a new version of the old thing that had an old wheel running against the against it. Power.
You do it by, oh no,
Power lights.
it's only the back.
I think they can also charge your cell phone. Looks like is this one a hub motor or not? No, I think it's just a hub. Yeah. That was a big comet. Looks like the Vancouver Hackerspace is here. We have a swap meet. Let's see what kind of stuff we got here. All electronics, these lamps, consumer electronic stuff. I think this is from the Hackery, which is a local electronics recycler. Nothing too much interesting. Audio fader stuff. Picture frames. Batteries. Oh, hey, Dreamcasts. MacBooks, business. What is this thing? It's a Sony. I'm not sure what this is. Signal interface switch. Must be a video switcher. Big audio power amp. What is this? Oh, this is a really old one. It's a induction motor driving it.
We saw it.
UREI electronic parts. Oh, it's heavy. Yeah, power amplifier. And over on this side, we have lots of, looks like solder. Two people solder. Nice.
Well, that's what I heard. I overheard the story. That's too bad. All that work. Is that one looks like?
Have you seen Ben?
No, I haven't seen her recently.
He's over here.
Girls around?
Giant sort of bicycle thing. Almost looks like it runs on rails, but that's not the standard gauge.
People do that. They like.
Here's a Tesla coil from the local science museum, Science World. Let's see what we got here. Rather tall secondary on that one. Just neon sign transformer and some caps. Here's some weird sculpture type things. at some of these Lego creations. Wow.
Then it technically hurt the water. And then by putting this beam across, this joint cannot physically come apart.
So we're looking into how one of our club members could do that.
Some sort of a flying city.
It's like their version of the Eiffel Tower. It's a business, restaurant, communications tower.
Okay, we have more things outside here. Food concession, some solar arrays. Who makes these? E-Dart, stay for energy. And what is this thing over here? I actually can't tell what this is. Some sort of robotics thing. Let's see, this thing is substantially hydraulically operated. We have hydraulic pumps, looks like Mars electric motors on them. I do not know what this is. We have some sort of human input device on it too. So I think we're all wondering, what is this thing?
Well, this is the alpha leg. It's a 2/3 scale prototype of one leg that's ultimately going to make up a 4-legged sort of biomechanical walking machine. And so the sort of inner part there is the actual leg, and then there's just a sort of
So
support
the
brace
thing
around
made with
it.
the tube frame.
Yeah, the tube frame, the square frame thing is just the sort of support structure. And then this thing over here is the human control interface. And so basically the whole system is a mechanical system. It's all powered by hydraulics. There's no software, there's no, computers making life easier, making it easier for you to pilot or control the machine.
It's like one axis on the control.
Exactly, controls one axis on the leg. And so the control mechanism there, you shift it along one axis, and one axis of the leg moves accordingly. And so this is basically our just sort of test bed and prototype that Jonathan, the chief mad scientist here, has been using to sort of figure out what works and how to build the larger scale device once it's ultimately ready. And it's all electrically powered. There's
powered by this
a big sort of lithium-ion power pack here that's been custom constructed and fabricated.
Nice.
That spins these big ass AC motors that then spins some hydraulic pumps, pressurize the system. There's a
This
I
some
can't
sort of a
remember what
reservoir?
this thing is called. This thing is impressive. It's a variable something. It's a variable pressure something. They invented it, and
Nice.
it allows them to dynamically control the pressure of the hydraulic system.
Cool.
It has a fancy name, but I can't exactly remember what it is.
So does this whole thing swing over?
No, so the point of the support structure right now is just to keep the leg upright, and so the leg can kind of
Like go up and
jump
down a
up
bit?
and down almost. But then ultimately, when it's done, each leg will be sort of independently controlled and articulated, and there'll be a cockpit. I don't know if you'll be able to see it on your video, but that's kind of what it's going to look like eventually.
Cool. So this thing will be about sort of as big as the trailer or a bit smaller?
It'll be probably about 15 feet long and probably about 15 or 20 feet tall. It'll weigh a good few tons, and if you're good at it, you'll probably be able to operate it at 10 or 15 or 20 kilometers an hour.
Oh, cool.
And it's specifically intended to be sort of what John called a sport robot. So it's not meant to be easy, because a lot of times technology makes life easier. Totally lost my place.
We were saying you get up to 20 kilometers an hour or something
right,
like
yeah,
that?
and so it's intended to not be easy, because technology, a lot of times it makes things easy, but you lose something when things are too easy.
Yeah,
it's like riding a bike. Like riding a bike, you get on, you fall down, you scrape your knee, but then you figure it out, and it's so much more satisfying because you had to learn it.
Yeah.
You had to learn to master that machine.
Like, I suppose this is something that could have been built decades ago. There's no new technology
Exactly. Whereas this is something that's intended to sort of have a learning curve. And for that learning curve to be somewhat steep, and so for you to ultimately have to figure it out and master it and not be able to just do it easily.
Yeah, we don't see that in many projects nowadays. Everything's controlled by computers. So this is something unique.
One button, one click, make it easy, make it simple. Sometimes things need to be hard because there's a beauty and a satisfaction in mastering
Humans don't know how to
hard.
do things a lot nowadays.
Exactly. And so we wanted to create a robot that wasn't an easy robot to control. And so ultimately, when the project's done, it's going to be big, badass, giant robot.
So what's this project called?
Prosthesis. The anti-robot. Yeah.
Okay. Yeah, this is really cool. I'd like to see this when it's running.
Yeah, definitely. It's going to be a couple years from now. We're going to be launching a crowdfunding campaign in the fall to try to get the money that we need to ultimately build the rest of the thing. Because the whole project is all run by volunteers. These guys are some of the welders and engineers and fabricators on the team, and so it's just a labor of love for everybody. Everybody's basically...
How many people on the project?
A good dozen or more.
That's a pretty good size.
And you know, different people bring different skills. We've got electrical and mechanical engineers. We've got, you know, software developers. I do marketing. We've got you know, a bunch of different people who do different things. You know, everybody is just on a purely volunteer basis, donating their time. We have some material sponsors that are, you know, hooking us up with things like power pumps and hydraulic systems and that kind of thing. But everything else has had to be sort of paid for out of the pocket of the team. Specifically, Jonathan is the principal.
Yeah, very cool project. Thank you very much.
Thank you.
They even have a car. So does it do like a force feedback through the...
Yes, it looks like this as you move the move this. It moves. I don't know if they're moving right now. But it moves these pneumatic rams in there. Yeah, you can see one of them moving. Critter there. There we go.
I might as well try it.
More stuff from eDart. This looks like a multi-person electric bicycle. Some lithium-ion batteries here. Hub motors. You know, just 4 people. And some bicycle generators. Okay, this is a giant mechanical snake. And you worked on the team building it. What's your name?
Yeah, Jonathan Fye.
Yeah, so this is really cool. This is all hydraulic, or pretty much hydraulic based.
Yeah, hydraulic based.
Yeah, so we have, how many sections is this built up of?
Yeah, so there are 4 independent sections on here that can essentially work on their own. You can see one of the section splits would be here, where there's only a communication wire in between. So it's essentially 4 machines all linked together and working together.
Right. So each one section has one hydraulic pump?
Exactly, yeah. Here you can see just the end of the motor. Hydraulic. This is an electric motor.
Electric motor, that's the Kelly controller.
There's a motor controller for this. And then on the other side is the hydraulic pump here.
Yeah. You've got flexible hydraulic
yeah, the reservoir was a bit of a challenge because you need to store a lot of fluid in a flexible space.
Yeah.
So we used a 2-inch flexible hose. It stores all the fluid and makes kind of like the spinal column of the snake.
This is sort of the filler right here?
What's that?
This is the filler right here?
Yeah, that's the filler tube, and to take up any air bubbles and that, they all come to the top, so that our pump doesn't suck any air bubbles in.
This has control on the obviously rotation axis, but it's
like a universal joint.
Yeah.
Each one, you could see it more clearly over here. This is without all the stuff. So we have one axis in this direction.
Yep, that's the sort of the slithering movement.
Slithering movement, and then we have another axis, you have to use your imagination, but here.
Is there any reason you made that control rather than just sort of following the ground?
Well, we wanted to have full vertical, like 2 degrees of freedom.
Right, like so.
So that we can do other types of slithering.
Oh yeah, like it could raise up and make a hump in the middle,
exactly,
sort of.
And we can do stuff like sidewinding as well.
Right.
So that's in the works.
That's really cool.
Right now.
So it's all controlled from one controller. This is the.
There's 4 microcontrollers, as well as one central microcontroller in the head that sends down the information, and each microcontroller on the 5 vertebrae control all the sensors and actuators, all the valves and the sensors.
So where is one of the microcontroller units?
Yeah, I think there's one with a you can kind of see through. So this would be one of the units here. So we use an Arduino base with we built our own shield on there with MOSFETs to control the all the valves, and they send like a PWM to the valves to open. They also takes in all the sensor values and does lighting and all kinds of other stuff.
Yeah. It's powered by RC lithium polymer batteries?
Yes. Yeah. They're 6-cell, 24-volt batteries, easily acquirable and fairly cheap for their amount of power output you can get. So.
Yeah.
Easy to place on the Snake too, because it's such a distributed design. To have like any kind of large battery pack with any kind of voltage, if you use like typical electric vehicle batteries, are just large and
they're
lower
pretty
voltage.
big blocks, yeah.
So we need something like this that's higher.
Yeah. So what voltage did the pumps run on?
24 volts.
24 volts.
Yeah.
So describe how you basically drive this. Do the microcontrollers take care of most of the slithering?
Yeah, essentially what happens is we give input commands to the head. Whatever you do to the head just gets propagated down, and it's pretty much the easiest way to do a slithering robot is that the rest of the body follows what the head does essentially, and you send it down at a certain propagation rate, and that way all you have to focus on when you're driving is the head. So you give it the input, the timing of your wave essentially, and the amplitude of your wave, and the rest gets filtered down, and every vertebrae does what the one in front of it does. And it's a very effective and cheap way of programming.
Yes.
Just 1 second.
So you've got feedback from the rotational position of each joint?
So this was we built up a sensor in here that essentially inside here is a small magnetoresistive sensor, and it measures
there's a magnet there?
Yeah, it's kind of like a Hall effect sensor, except that instead of measuring the power of the magnetic field, it's measuring the angle of the magnetic field. And it's taking magnets that we glued on here and measuring the angle of that magnetic field inside this sensor. So we potted these sensors inside of a small aluminum tube, potted them with epoxy and then, for protection, and then buffered them and cinched them down. So they're not going anywhere, they're nice and protected. Our first design was to use resistive pots coming off the angle, the top of the bolt. But that created like a top.
Adds a bunch of height,
height, and it was very delicate.
And it's a mechanical thing that's prone to go bad.
So this is nice because it's enclosed in here, and because the magnetic field can obviously pass through the aluminum, it's quite enclosed.
Yes.
It's a nice design. We're actually pretty proud of that.
Yes, this is very, very nice. So what does the controller look like?
The controller is actually still in its first revision. We have plans on making a new controller. This is one of our guys that did the software programming. He took it upon himself to do a design. We have added some other controls over time, but it's very, say, 80s arcade style right now.
Yeah, it does look like that.
Digital, simply a digital 8-position
just digital switch
with micro switches on the joystick. So essentially what we're using now is just the left and right signals, and it's a matter of timing. You hold it in one direction to keep going that way, and then you switch directions and hold it. So it's all, the timing is done here. But obviously there's many improvements that we can done on that. Our next revision, one project that I'm working on, is to use more angular sensors and position sensors on your arm, and they can be measuring like digital compasses that are measuring the directions.
Right.
And so you could use your arm to control the Snake, which would be a neat improvement. So.
That would be, yeah. Is this based on an Arduino?
There's another Arduino in there. We got a lot of Arduinos around with XB technology to communicate.
Nice.
It's chose to go with that because it's low barrier of entry for new people joining the group.
Yes, that's always a good idea.
Everyone knows how to use it. If you chose a type of proprietary microcontroller, it'd be a higher learning curve and stuff like that. So.
Yeah, and you don't really need super high performance for this.
Not really. We do need a higher performance on our communications line, but that's still in the works.
Anyway, this is an awesome project. Thank you very much for letting us know about it.
Yeah, no problem. Oh, here he goes.
So cool, Dad, right? So cool.
And that pretty much concludes all the interesting stuff with Vancouver Maker Faire 2013. There's a lot of other stuff here, but that's mostly sort of arts and crafts stuff. Anyway, I hope you liked this video. Thanks for watching.